Hello, this recording is about flash memory. Flash memory is non-volatile semiconductor storage. It's made of electronic parts. It does not have any movable parts. It's much faster than hard disks, maybe thousands of times faster than a hard disk. They have many advantages that make them suitable for many modern applications, like they are smaller than hard disks, they consume lower power, and they are more robust. They withstand more shocks, but they're more expensive. They cost more per 1 gigabyte. Therefore, they have a lot of uses, but still for mass storage, hard disks are still used. There are two types of flash memory, the NOR flash and the NAND flash. The NOR flash is named because the bit cell is like a NOR gate. It has many advantages. You can randomly read any word and you can write any word. Therefore, used instead PROM applications. For example, the instruction memory of many embedded systems is a NOR flash memory. The second type, NAND flash, is named because the bit cell is like a NAND gate. They are the most used flash memory available today. They are denser. You can have more bits per area, but you don't read or write one word at a time. You must access one block at a time. They are much cheaper than NOR flash, and as I said, they are used in many applications like USB keys, media storage, SSD storage, mobile devices, cameras, and so on. I'll show you a video about flash memory at the end of this recording that explains flash memory in detail, but one of their main disadvantage comes from the fact that in order to write, you need first to erase the previous contents. Erasing, writing, these cycles damage with time, wears out the flash memory, and with time you cannot do any more erasing and writing. So they are not suitable for direct RAM or disk replacement. So there are some applications where you have high rate of modifying data. In this case, flash is not appropriate. DRAM and hard disk can withstand many write cycles. In order to avoid this problem, many applications and operating systems do wear leveling. Wear leveling means remap data to less used blocks, try to erase and write different areas of the flash, not keeping erasing and writing the same location. Now I'll show you a video from Microchip titled "What is Flash Memory?"
Hello and welcome to Microchip's Memory Technology Series. So, what's flash memory? Well, flash is the current king of memory ICs in terms of both units shipping and money being made, because it is the lowest cost per bit memory on our planet today. It is non-volatile, which means the data is not lost when power is removed. Thumb drives, soft disk drives, micro SD, BIOS boot memory. This integrated circuit idea has really changed our world. This is an EEPROM gate symbol from vintage 1980, and it's the same as today. And this is a flash gate symbol. In 1980, Japanese scientists noted that this extra gate here on the EEPROM isn't needed if the user doesn't need to rewrite just one byte at a time and can wait and erase a whole section of the integrated circuit instead. In that case, the part is half the cost, half the gates, at least. By 1990, Flash was already shipping millions of units. Flash gets its name from the requirement to do an all-bit bulk flash erase of a whole sector or block of the memory anytime even a single 0 bit in that sector needs changed or reprogrammed back to a 1. Okay, disclaimer time. You know, Flash is a huge business with many competitors. Our information here is just the basics, so expect the information you find in the datasheet of your target product to be a bit different from this video. That's great. This video is your starting point. So, now back to our video. You buy your Flash completely erased to all ones. Then, when you first program or write it, inside only the bits needed to move to 0 are programmed. For example, here byte A7 is created by writing just these bits from 1s to 0s. Moving these to 0 can happen relatively quickly. Think 50 to 100 nanoseconds per byte to write a Flash. But the second time through, if you ever want to change this byte from, let's say, A7 to AF, so just this one bit needs to move back from 0 to 1, things slow down. Not just this byte, but the whole section of the IC will need to be erased, and all the content will need to be copied in again with just this one bit changed. To understand why that is, you might want to watch our video on Fowler-Nordheim tunneling. Okay, so let's go over the key concepts. Flash is non-volatile. Writing the part the first time or after completing any sector or IC erase is quite painless and quite fast, but erasing the part to rewrite it a second time and thereafter is, however, painful. It takes milliseconds of time to erase a block or sector and minutes of time to fully erase your IC. Watch some of our Flash and Super Flash videos if you want to understand this technically. You have to erase a whole sector or block just to turn one bit in that block back from a 0 to a 1. The lowest cost flash type is NAND flash. That's the integrated circuit in memory sticks and soft disk drives. Because of its NAND type layout, it comes in gigabit sizes, but must be written and read in a string of consecutive addresses. NOR flash is a bit more expensive than NAND flash because of its NOR type structure, but can be read in random address calls, making it the right part for BIOS, boot codes, and configuration settings that aren't constantly being updated. Microprocessors, microcontrollers usually have a NOR flash block inside, though buying an external flash IC to supplement the onboard flash is really quite common. Writing your flash slowly damages the memory structure. Again, see our other videos to understand why that is. Most new NAND flash parts specify only 1,000 to maybe 10,000 erase-write cycles before destroying the part. NOR flash number is more like 10,000 to 100,000. Here is a rough density chart. EEPROM dominates only at the very bottom, where the unit price difference is small and the byte write capability is important. NOR flash is here in the middle where the boot code densities fall, and NAND flash stretches up as far as the newest technology can reach in gigabits. Now this chart takes a shot at cost per bit, but only to show you how the costs relate to each other, because market pricing varies with time, as we know. NAND is cheapest by far. DRAM and NOR flash have somewhat similar costs per bit at their best relative density points. Then comes SRAM and then EEPROM. There are also a slew of other specialty memory types that are priced well above these big volume families. See our other videos to learn more details about various memory technologies, terms, and other memory concepts.